All right, so guys, thank you for coming. So we got a 31 of you today. That's good, but hopefully your colleagues who couldn't make it to the meeting, they can also watch the recording later. So the main purpose today is really for those of you who are struggling, maybe you have started Lab 1, or maybe you haven't started, but just to really, haven't seen share the screen. Yes, I'll do that in a moment. Yeah, maybe I should do it now. Yes, I haven't shown anything yet. Thank you. Okay, so now you can see my screen, I suppose. Okay, that's good. So today the main purpose is really to give you some guidance about getting through the lab. And then I'll walk with you maybe instruction. I wouldn't explain in detail because that's something you will read by yourself. I don't need to waste your time. If you got specific questions at the end, let me just spend the initial maybe 30 to 40 minutes. I do have something based on your colleagues which who I have helped so far. So I can explain those questions to you first, and then you can ask me questions. We'll see how long the session will go. Depends on you, but maximum 90 minutes. I guess everybody got other things to do. All right, so let me first of all switch to my iPad. I want to make a quick announcement first. Okay, so in order to do lab numbers 1, okay? Okay, actually, it's just about this is important. So currently, our scheduled labs are on Wednesdays only. I know some of you may have to work. Some of you may have to worry about other courses, maybe schedule conflict, whatever reason. So I'm based on the survey I sent out from to you. For those of you who responded, I look at your preference, and then I share the preferred slots with the TAs. I'm currently coordinating with them just about which slots we may schedule some extra lab sessions. So hopefully that can also help you. Okay, so you can expect an announcement maybe from me over the weekend. So I'll let you know exactly what's going to happen over the weekend, so we can start helping you with the extra sessions from Monday. Okay. Yeah. Okay. For lab number 0, I believe most of you have finished that already, or very, very close to finishing it. I would put it this way. So in order to do the implementation part for lab number 1, you will need the basics that's covered in lab 0. But of course, at the end of the today's session, if you got any confusion about syntax, I can also try to clarify quickly for you. And you also got lecture series week number 2. So you might be wondering, would that help me on lab 1? So I would say it's mainly about the postcondition that you have to write. So we didn't give you any violation tests for your lab number 1. So we would expect you to actually write violation tests yourself, because we already covered that in the Lab 0 tutorial videos. And to really write a more advanced postcondition that might involve maybe the old keyword, or maybe a twin, deep twin, etc. So you will need the lecture contents from week number 2. And don't forget, we also got our weekly quizzes. So quiz number 1, maybe all of you have finished that already. You will be closed 5 p.m. today. And also, I'm going to open up the quiz for week number 2 as well. Okay, just to let you know, everything is on schedule. Okay, so now, before I move on to my agenda, for lab number 1, so there are a number of resources given to you. Just make sure whenever, let's say the TAs or myself, we are not around. So you should really consult with these resources first. Maybe you can find your answer already. Okay, just you want to consult with all the things that are given to you before you ask questions. That can save your time, right? So for lab number 1, you definitely should really look at the PDF, which I'll go over with you, just tell you which parts you should really look for, maybe in the beginning stage or the later stage, I'll tell you, okay? And also, you also need to look at the starter project. Of course, that's the project you're gonna edit and then submit eventually. And then I'll give you some walkthrough about the sequence of the features you really do. It's pretty straightforward, basically sequential. I'll point out something. And then the tutorial videos, I would say, is really optional, because the tree node class that you're going to do, it basically just about how you can build binary search tree, which you learned already from the previous 2011, the data structure course. So if you're comfortable with all the concept over there, like in order traversal, about counting the nodes, etc., you don't need to bother with the tutorial videos, okay? However, some of you actually put a question on the chat, so I can respond to you briefly now. I can elaborate on my answer a little bit later. You talk about splay tree, okay? The splay tree, which I'm not sure how many of you may have learned in 2011, but I think typically when they cover balanced binary search tree, they will mention at least one kind. I think AVL might be the popular kind that your instructor might have mentioned, or splay tree. I've heard about both versions actually from my previous students. But if you haven't learned about splay tree, don't worry. So the intention will be, if you look at the instructions there, which I will tell you which part, and that summarize all the facts you would need to know in order to implement. You don't necessarily have to know why things are designed that way. That's more like the theoretical part, which is beyond the scope for this particular lab. And then later on, when you want to implement the more intermediate and advanced features in the splay tree, like a rotation, splay operation, insert, delete, and search, for those, if you're already comfortable with the written PDF, you don't have to bother with a tutorial video. But for those of you who might need more visual guidance, okay, and there is also a website about how you can build a splay tree. That's also handy. That's also covering the tutorial video. They're not that long. Maybe within 1 hour, you can finish all of them, okay? Anyway, so that's about the initial announcement. And then I think that one of the struggle I heard during the office hour or by the appointment was about how you do recursion. So that's something I would like to talk about as well. I'll give you some examples. So hopefully that will help you. Maybe just struggling with the syntax. Okay, in which case I'm happy to help. Okay, so now let me start with, I'll get to the recursion in just a moment. For those of you who may want to get ready, why don't you launch your iPhone Studio and get iPhone New, the website, get it ready, and I'll do everything together with you. Okay, but before that, I'd like to go do something a little bit more static. Okay, just about going over some instructions. Okay. For now, I'm not going to look at the chat, but I'll do that maybe a little bit later. Okay. Let me see if anybody wants to join in. Okay, let me just admit them. Okay. Okay, so on your e-class page, of course, you got the instruction over here. Okay, also you got to start a project. Let me highlight one more thing. Okay, so there were some minor typos in your comments or in your hints reported by you guys. So we fixed them already. Okay, so it's been updated since 10:30 a.m. On Wednesday. So it's been 2 days already. So for those of you who may actually got a slightly earlier version, you may want to update. Okay, it's very minor changes. And to really see what the changes are, when you see the instruction, this at the end, there is an amendment section that tells you what has been changed. Okay. Okay, let me just tell you the instruction very quickly. Okay. So first of all, just remember about the deadline. Okay, you got just slightly more than a week. The Lab 1 has been released since Monday. So please, I'm sure you joined in the session because you care. So you want to really get onto it. Okay, and then drop by the my office hour or the lab session next week to get help and then complete it in time. We have to move on with other items for the course in time as well as scheduled. Okay. Okay, so now you know about the policy over here. Okay, I'll let you read it. Okay. So let me talk about different sections. I'll just go over quickly. Okay, I wouldn't dive into details unless you have specific questions. So this particular lab assumes that you have finished the lab 0 already. But although if you're only about maybe halfway through, almost done, you can also start with Lab 1. Actually, we're kind of expecting you might do the last part of Lab 0 simultaneously with Lab 1. So I think for the basics part about Lab 1, just by done half of the Lab 0 is sufficient. Okay, you definitely don't have to wait. At least at this point, you don't have to wait until you finish Lab 0 in order to do the Lab 1. That's not the wise use of your time. Okay. Background readings, etc. So now pay attention to section 3 over here, some important syntax to know. You might find it useful. And also you will see that a similar pattern has been used also in your starter code. If you're wondering about what it is really about, you can refer to section 3. It's about how you use the attached syntax. I'll let you read it, okay? Okay, section 4 is really about a summary of binary tree, binary search tree, also splay tree, etc. Right? I would say 4.1 about binary tree is just about the tree nodes that we give to you as a starter code. You definitely should go over that. And then for 4.2 is about the properties of binary search tree. And one confusion you might have is about external nodes and internal nodes. Let me just mention that quickly, okay? Because I heard, observed some foreign questions and also some students from the in-person session. So visually speaking, each tree nodes can either be internal or external. Okay, either internal or external. Visually speaking, you can think about internal node is like a circle. Okay, external is more like a square. Okay, you can think about it. Internal node is not void. because you do have an object. Also, external is also not void. That's one of the confusion I just clarified on the forum. Okay, you can read that forum as well. So now for internal nodes, both of their left child and right child, they are not void. Okay, for example, the left could be just another internal node. And then its subtree can be arbitrarily complicated. So we can draw it like that, right? This is the left. On the other hand, its right child can be either internal or external. I just draw external to show you. So you can see in the case of internal nodes, both the left child and right child, they indeed are objects over there, so they are not void. On the other hand, in the case of the external nodes over here, both the left and also right, they are just void. Okay, that's how you can tell. And I want to draw your attention to, I might just get there when I talk about starter code. So when you go over the starter project, even though this time we don't ask you to do the invariants, but you should really read over the class invariant in the tree nodes. It does clarify some confusion you might have, especially, for example, internal nodes versus external. You will see predicates over there. Okay, so they are also part of something you should learn from this particular lab. Okay. Okay. All right. Yeah, so guys, just to remind you very friendly, so to avoid yourself to get into trouble, so just avoid talking any too many details about your assignments, your lab 1, or post any code. Just be careful, okay? If I do think I need to show you any code, I will show it to you. Okay, I will judge. Just be careful. Alrighty. So split tree. Okay, so maybe many of you haven't learned about split tree. That's okay. You know, every lab might introduce certain concepts. You have to do a little bit background reading. So now let's say this. Split tree over here, I'll let you read it. So it's a very quick summary about split tree. And this part over here is optional. For those of you who might be interested in learning more about split tree, it's a very prominent data structure by these two scholars. So if you're interested, you can feel free to read it. It's only for those of you who want to explore further. And then the most important part about split tree is about rotation and also about split operation, right? For details, you have to read the summary, okay, and then to understand the examples there. I will talk about rotation in just a moment. I do have one iPad page to show you. Okay, I'll get there. I'm just telling you, these are the sections you're supposed to read, okay? But in order to finish just the basic features for this lab, you don't necessarily have to get to split tree just yet. But as you see in the grading scheme, by finishing all the tree node features and the basic one in the split tree, just a basic one without any rotation, you already get a D+, right? According to the instruction. But of course, we hope that you'll finish every one of them. All right, let me go a little bit further. Okay, that's about how to do self-adjustment for split tree. That's something you got to read as well. If you got specific questions, I can answer either today or during my office hour. Okay. Okay, and then this is actually a website over here. Okay, let me click on that quickly. So this is a website not developed by us, but I just Googled a little bit. So I found this particular tool. It's actually a very, very nice one to actually illustrate to you how the insertion and deletion are working for split tree. You can even slow motion, like using breakpoints of the tool. So if you consult with one of the tutorial videos, I recommend, you can definitely see how to use the tool. Okay, I'll leave that to you. If you got trouble, you can also speak to me during the office hour. Okay, so now let me go back to the previous page. And then, so section 5 over here, as I said, is really optional. You don't really need to watch the videos in order to finish the lab because all the written instruction in the previous section already cover everything. But if you just want a little bit more visual illustration, you can consult with these videos. Okay, I'll leave them that to your decision. Okay. Okay, so now about getting started, you have to download the starter project, of course, and then run the test cases. Initially, you might have some test cases passing. That's because some implementation has been supplied to you. So you should really start with the first failing one and then to see why it actually fell. So in order to really see why each test case might fail, number one, you should really learn to read the test case. As I said, it's a precise documentation for you. Okay. Number two, you may actually want to set breakpoints and launch debugger to see why your current implementation might fail that particular test. And we covered that already in the tutorial series. So I would say the number one most important learning outcome from the Lab 0 tutorial, well, maybe syntax will be the number 2 learning outcome. But number 1 will be how to use breakpoints and debugger. That's really the knowledge that's transferable to other courses or your future career. So really pick it up. All right, so this diagram here, it's optional here. For those of you who might be struggling a little bit how each feature calls what. So this is like a call graph over here, right? For example, let me make it a little bit bigger. I should help you read one of them, okay? You can see there's a legend over here. You can see the legend. And then let's say, for example, over here, we're saying that the value search query or feature in the tree node class, that one calls this particular has feature, okay? So that kind of gives you a little bit more idea about how things maybe call each other. Okay, so now, okay, let me just admit one more. Okay, let me continue. Okay, so now section 6.2 is really important. So if you really get stuck, but somehow it's really outside the scheduled labs or the office hour, you should really consult with section 4, the problem, and section 5, optionally, if you want to see more visual demonstration. And then you should really learn how to read the test cases about starter tests and also example tests. Okay. And then we also wrote comments and also hints for almost every feature. So you should also read them. So in order to give you some guidance about how you can move on. And also, yeah, hints. Okay. And then this 6.3 is just about, so we try to organize the test cases in a way that whenever you want to find the related tests for a particular feature, you have to go to a particular section in the starter test. So this section here explains to you how you can do it. Okay, the instruction is very detailed. I'll leave that to you to do it. If you cannot do it, let us know. Okay, grading scheme, that's pretty clear. I wouldn't cover too much. I just want to let you know, we already gave to you 55% of all the grading of all the test cases eventually that your submission will be run. The other 45% will be something that will run once you have submitted your grade. And then you can see more details about what they are about. Okay, but you can already get 55% guarantee if you get a green bar, right? All right, so for submission, I haven't opened up the submission yet. I will hope to do this by the beginning of the coming week. As soon as I'm done with the submission, I'll let you know. So for now, just don't try yet. But as soon as you can try submitting, I'll let you know on the e-class. Okay. Okay, and then submission instruction, and then, so here just some minor, well, the list, actually it's not that big. It's just about what comments or what hints we have changed. It's just mainly just typos, okay? Nothing logical. All right, so that's about the PDF instruction there. Okay, I will simply just go on with the next item on my agenda. Okay, I do have some question over here. I'll get there in just a moment. Okay, I'll get them together with the chat questions. The next thing I want to do is to give you a little bit idea about recursion. Okay, so because there will be some recursion you may want to write for your Lab 1. And I think what you're suffering from may be just about how to write recursion in a new language rather than conceptually. Okay, so I'm just gonna do to review a little bit, what kind of recursion you can write just in IFO using a different example. So you can feel free to actually transfer the concept to your Lab 1 or later. Okay, so let's get ready. So now why don't you go to the IFO new website from your Lab 0, right? So now what I would do is I'm going to have a new project over here. Let's call that recursion. And then you can say submit, okay? If you cannot really catch up with me, that's okay. It's going to be a posted recording so you can follow up. Maybe just focus on understanding what I'm trying to type over here. I'll put it on my desktop maybe. And then I'm just going to recursion over here. Okay, and then let me just open that on IFO Studio. Okay, so now let's say add projects, desktop, and then also recursion and recursion. Basically, I want to show you how we can write. In Java, I call it recursive helper methods. But now method can either be an accessor or mutator, right? So now in IFO, a recursive helper routine can either be a helper query or a helper command. I want to show you both flavors. So now you just get all the syntactic help you will need. And then the rest will just be to figure out conceptually how you should do the recursion. Okay, I think that's something you have to do by yourself. Okay, so now let's do a very quick setup. Okay, I'm not going to worry about deleting this argument 32 as you did for lab number 0. Okay, I'm just going to get rid of this guy here. Okay, I'm not going to bother renaming the test example. I'll only just go to test example over here I will just, for now, I'm just going to, let's say, leave one thing over here. Just one test, just for now. I'm going to rename it in just a moment, okay? Just make sure everything compile. Okay, it will just fail in the beginning, so let's not bother even try. What I will do is I'm just going to create a new class over there, and then we'll go from there, okay? Let me just refer to my notes so I will know what to type so more efficiently. Okay, so now let's create a new class over here. Let me show you how you can do recursion on array. And how you do recursion on tree or on any other data structure will be very similar, okay? I don't want to get the example too close to your Lab1 because that will actually, that will actually let you miss the learning opportunity. So I'll just show you something that's good enough for you to move on. So let's type the following, let's say linear container. Okay, and then I'll say creates over here, okay? Okay, for linear container, what I will do is I'm just going to, let's set up things first of all quickly. So let's say we're going to have a constructor over here. So I'll say creates and then make from. Okay, I will do that in just a moment. And then we got feature attributes. Let's say we got one attribute. Let's say how we represent a linear container. Let's say rep over here. Let's say array of string. Okay, we're going to do recursion on this in just a moment. And then I'm just going to have the constructor over here. So let's say comments. Let me just maximize it. Comments. And then I would say make from. And then let's say it will take just another new array. So I can say new representation. And then let's use anchor type like rep. Okay, you will see also usages of the anchor type in your Lab1. So now let's require the following. So we typically make the assumption that array indices will start with 1. So let's just encode that assumption. So lower index will be the new rep, the input parameter, that lower is equal to 1. Okay, and then we say rep is assigned to new rep. Let's not worry about the postcondition. You can definitely do it as an exercise. I want to get straight to the point. Okay, and then we're going to have basically 2 versions of the recursive routine. Okay. Let me just put the feature section over here. Okay, feature. Let's say recursive queries, version 1. Okay. Recursive queries version 2. So we'll show you 2 versions. Okay. Let's first of all make sure everything is compiling. And okay, so let me just go back to the test. You want to make sure the test is actually referred to. So just for now, I'll say local here. Let's say, just give me one moment. Let me take a look at how my test has been set up. I want to be consistent. So what we can do is, okay, so now what we can do, let's say C, that will be linear container. Okay, so just for now, we're gonna do the rest in a moment. Okay, everything compiled. So now let me go back to my linear container. Let's do the first one. So what feature do we want to create? Let's do a very easy one, okay? The easy one I want to do is this one here. So I would say, let's say contents. I want to retrieve the contents. You can see currently we simply got an array of string. Let's say we simply want to convert from an array of string into a linked list of string. But we want to do it recursively. Well, practically speaking, you may not want to do it because you can just use a cross loop. But I just want to illustrate recursion to you. So let's pretend that's what you are required to do. Okay. Let me see if anyone is on the waiting room quickly. Okay, nobody. Good. Okay, so now we got let's say contents 1. Okay, I'll just write the comment just for the first one. Okay, I would say convert rep, which is an array of string, to a linked list. Okay, I'll put a return type in just a moment. So now this is a comment over here, and then contents 1 is going to return a linked list of string. So you can see that now the intention is we want to convert from array into linked list. Okay, that's what we want to do. And then let's see how we can do it. So now think about how you would do it recursively, or even in Java, right? So now what we want to know is how you can do that syntax in IFO. I would say it's pretty much the same. The only difference is if this is a query, it has a return value, as we learned from Lab 0. You just don't have the ability to really use a return keyword. So all you got to make sure is the result variable that's by default, right? It's created for you, actually contains the value you want to return. That's all you got to do, right? So let me show you the two versions, okay? So let me, let's say this one. First of all, let's create result.make. As you can see, result is linked list. Well, again, from Lab 0, you might be wondering about, we talk about programming from the interface, but not from the implementation. So ideally, this might just be a list. So you can have the freedom to really create dynamic type being linked list or two-way sorted list or etc. Right? But for now, just for illustration, I'm going to put linked list directly. Okay, so now say create result.make. And remember, in order to compare the elements of the collection by their objects, by their is equal. So you have to say result dot compare objects, okay? You don't necessarily have to call this every time. You have to judge when you might need it, right? You want to think about when you use tilde, do you want to compare every member in the collection using object comparison or reference comparison? So you had, and then you would act accordingly. Okay, let's say now we want to compare objects. And then, so now I'm going to show you how you can use a helper routine, okay? So in general, one of you guys also asked me, would it be recommended if you use a recursive helper routine? I would say the choice is completely up to you. Maybe back in 2030, you're always forced to actually use a, in the 2030, you're always forced to use a recursive helper method. But now I would say now you're in the third year, we believe you know how the recursion works. So sometimes you might be able to get by without the recursive helper routine. So what I'm showing you is just a general approach, okay? If you are able to collapse the two routines together, feel free, okay? So let's see how we can do it. So now the first version I want to show you, the recursive helper routine, is actually a command, okay? So now what I would do is, you can see result is already being initialized to be empty, right? So now we want to do a little bit of trick called call by value, which you learned in 2030, right? And I'm not going to test you on this, but for those of you who don't know what the call by value is, you will see my illustration, but for details, you may want to refer to your notes earlier or consult with me during the office hour. Let's say content helper 1. So now this is going to be a command. So it does not need to, so it does not have a return value. So the call can stand alone. So some of you also have the question on the forum. For example, let's say when you call the celebrates query from your Lab 0, when you're trying to create a test for that, if you only say bb.celebrates and stand alone, it wouldn't compile. It would say the function call is used as an instruction, something like that. What you should do instead, every time when you call a routine that has a return value, you need to have a variable to be assigned to. So that's the requirements, okay? Content helper 1, so let's say I'll simply put 2 arguments. I'll show you what these 2 are. So let's say result. So you can see it's really a call by value. I'm passing the address of this particular result, which eventually will be returned. I'm just passing its reference to the helper method. So the helper method is going to be called recursively. So there'll be many levels of recursion, and then each one of them is going to manipulate the same objects pointing to the same result, okay? And then result over here, and then I would say let us start with 1. You can think about we're going to move basically left to right in the array, and then we're going to start with position 1. As soon as we get to rep.count, the maximum index, then we should know to stop, right? You should always have a base case for recursion, right? All the concept you learned from the previous Java course about recursion, implementation-wise, is the same in IFO. What's new is about the contracts that you have to learn in this course. Okay, so now let's see how we can define this particular helper command. Okay, it's pretty easy. Let's see. So I can say contents helper 1, and then I would say list over here. So I'll say linked list of string, and then I of type integer. Okay, you can see the result over here is matching this list over here, and then 1 over here, the current index to look at is I over here, right? Okay, and then I'm just gonna omit the description for now. Okay, so now we want to think about what might be the base case, what might be the recursive case. So what we can do is we can say as we're gonna recur as long as the index I over here is still valid, which means we can still insert into the result list, right? So what we can do is, let's say this. If the index is actually valid, which is I, less than or equal to rep.count. Remember, rep is actually the array that we are trying to go over, right, in order to return the linked list version of that. So now we say if as long as I is less than or equal to that, so that means we have to recur. How do we do that? First of all, so every time when you talk about recursive case, you got to do something small and then let the rest of the recursion handle the rest. Okay. So list dot extend over here, and then we say rep array at position I, right? As you can see, this particular indexing notation is very efficient, right? Indexing into the array. Okay, I see another guy who wants to get in, emit. Okay. And then, so now I would do, so now what's the rest? Guys, let me pause a little bit. This one I can ask for your opinion. What I need over here is a recursive call. Any suggestion? We only got one line left for this particular recursive helper command. Okay, anybody want to help me out over here? I already insert the current element into the resulting list, call by value, right? Now I just need to make sure I can actually keep doing this insertion for the rest of the array recursively. So now I just need one more line over here. What line should I type? Anybody?
Could you put maybe content helper 1?
Okay, thank you. Okay, speaking out is okay, don't worry. Okay, can you say it again? Content
helper 1.
Content helper 1?
And yeah, inside it, you would have rep at I plus 1. Actually, no, sorry, list.
List. Exactly, very good. Thank you so much.
And then I plus 1.
I plus 1, exactly, very good. Right, you can see there's nothing new over here, so it's just about getting used to the syntax you're writing, right? Conceptually, it's the same. Nothing conceptually new. Thank you so much. So that's good. But test-driven developments, we should really try to test it right away. Okay, I'll do it over here. I'll make this tutorial, this part of the tutorial, very complete, so you can definitely follow it. So I may not do any tracing together with you today just because time is limited, but definitely study the two versions I give to you. If you got any trouble tracing them, please speak to me. I'll be happy to go over with you. So now let's do the following. Okay, let me go back to my notes over here. So now let's write this. Let me just rename this over here. So test recursion 1 and then Boolean, and then I just need some local variable to help me a little bit later. Okay, let me set it up. So I would say list would be a linked list of string. Okay, and then of course you got to give the same name. Okay, and then I would say over here, let's say test recursive helper command. Okay, so now let's see how we can do it quickly. Let's say we just consider a very simple case. Let's say first of all create list dot make the local one. And then list dot extend, sorry, not exhaustive. Extend, let's say Alan, list dot extend. So this will be expected list, the expected outcome. Mark, list dot extend. And also Tom over here. Okay, so far so good. And then since we're gonna compare objects, remember the over here when we did this particular version 1, we said we compare objects. In order to use tell that later, we want to make sure this expected list also compare objects. Don't forget. Okay. So I'm gonna say list dot compare objects as well. Okay, so now let's create the linear container. I can say create c dot make from. Okay, that's the array over here. So now I'll just write out the array. This is the notation I didn't show to you on Lab 0, but I'll just show you now. You can write an array right here. But there's one caveat I got to give to you in just a moment. Alan, Mark, and also Tom. Whenever you write this particular expression over here, of course, in Java, you will simply use curly brackets. So now we're just using double angle brackets, the same idea. However, one thing I want to note to you here, okay? When writing array like this, its object comparison is false, which means by default. Okay, if you want to set it up, you need to assign this particular array to another variable and call compare objects on that. Okay, just a very quick reminder to you. Okay, so now we can do result is assigned to C dot. So we're calling version number 1, right? The recursive routine we just did is tilde equal to, right? We're comparing two array and list. And both of them are comparing objects we have set up. Okay, that's an easy test. Feel free to extend it if you want to play with further. Okay, unknown identifier. Yes, exactly. I just rename it. So let me change that name as well. Okay, everything compiled. Let's take a look at the test result. Okay, green bar, right? Test-driven developments before we move on to the second version. Okay, guys, I'll take your question maybe at the end. Okay, so now let's tell you about version 1. So the main learning the main message for you to pick up is you can definitely try a particular recursive helper routine that is a command. Okay, and for the same problem over here, I'm going to show you how you can use, rather than a recursive helper command, you can do a recursive helper query. Okay, and the main thing about recursive helper command is you use the call by value property of OOP that you learned from 2030, right? That's the main thing. So let's do the recursive helper query, which you might struggle a little bit more because you cannot use the return keyword. Okay, let me now again go back to my notes over here. Okay, good. So now let's define version number 1. So we'll say contents, let's say contents, okay, contents 2, okay, version number 2. Again, the same return value, linked list of string. I will need your guys' help in just a moment, okay? And then I'll say do and end. And now this part here, we don't need to do any, we don't need any call by value anymore. Okay, so what we'll do instead, we can say result over here. So the result list over here, right? Result is linked list. Is assigned to the return value of the helper query. So I'd say content helper 2. And now I don't need the call by value anymore. What I need will be, I just need to know what's the current position I'm at. Okay, so I'll simply put, for example, 1 over here. So in some way, it's a little bit easier in terms of signature, but computationally, they are the same. Okay. Okay, so now let me go a little bit further. So let's say, how do we define the helper method, the helper routine? So we can say contents helper 2. And then we only take I, the integer. And then, so now you can contrast. In the case number 1, it's a command. But now in case number 2, we're going to put a return value, which will be linked list. And then I would say string over here, okay? So now I just need over here. So let me just get to the point that most, well, not, I shouldn't say most, maybe some of you might be struggling, okay? Based on what I learned from the appointments. Let me say creates result.make. Think about this particular content helper 2. When we call the actual recursion at the runtime, this helper routine might be called many times. Each time is going to return just one portion of the. Let me give you this one. I can give you just a quick illustration. Okay. So now thinking this way. At the runtime, let's say this. First of all, we try to call content 2 over here, and then we're going to call the helper 2, and helper 2. Each time, we're going to increment the content 1 and 2 and 3. Because for this particular array, the valid index is only up to 2. So now when you get to 3, that's the base case, in which case you have to return, right? So now let's think about what's really going on here. You can think about when we actually get to 3 over here, so that means what it will return is simply just an empty list. Just empty. It's like the sub list starting from position 3, in which case nothing. Okay. So what about when we make a recursive call on 2? So that means we're going to make a sub list starting from position 2. In that case, you will just return one linked list of the node B. So that's the result. And when you actually call, let's say this one here, 1 here, in that case, you're going to return a sub list starting from index 1. So that will include 2 as well. So in some way, it's going to be like this. So A and then B. So that's the final outcome. So you might think maybe space-wise, the recursive helper query seems to be more expensive. It is true, but I would say for this course, we are not so worried about the efficiency concern. So as long as your loops or recursion will terminate, we are okay with that. So I just want to give you the most straightforward solution to it. But if you want to make it more memory efficient, feel free. Okay, I just want to give you the idea. Right, so eventually, what we will do is we'll return this particular list, which will be the linked list version, right? All right, so let me, having that kind of intuition, So let's now see how we can program that, right? Let me just set it up a little bit further. So I should say result dot compare objects over here. Okay, that's good. And now, again, we want to talk about base case and also recursive case. Well, similar. So we will only recur if I is a valid index. Rep dot count over here. Okay, so now, well, what should we do over here? Think about in this way. I'll give you one visual hints, and then I will see if anybody would like to contribute, and then we'll finish that. Okay. So basically, you can think about content helper 2 over here could be potentially. It could be maybe. Sorry. It could be maybe this particular call, or it could be this particular call, or it could be this particular call. Right. In case we are doing, let's say this one over here. Right. So that means we want to do from index 1, in which case we got A already. But now we also need the rest of the array in order to be converted into a linked list. For that part, it should be a recursion. All right, that's kind of like a very quick visual hints for you. All right, let me come back here, guys. Any idea you would like to contribute before I tell you the solution? Anybody? I'll pause a little bit so you can have enough time to think about. You can either type on chat or you can speak up. Either way. This one could be a little bit trickier, but that might be what you might get struggle for Lab 1. So I think it's worth giving you a slightly different context to show you. How about we start with this particular guy? We can say, well, since I know that current index is simply I, right? So I should say result list, which I'm going to return implicitly, should at least extend by the representation I over here, at least. This part here is very similar to the line from the previous version. So conceptually, they're really the same. You want to just do a little bit of job over here before you pass on to recursion. All right. Okay, what about the rest? How do we finish that list? We want to really extend that list a little bit further by whatever that's returned by the rest of the array recursively. Anybody? You can even just tell me your idea, and then I can help you translate that into syntax in IFO. Okay, I see Andrew actually make some thoughts over here. Let's talk about it. I see Andrew. I see also Bie Shen. Okay, so similar idea. Let me just talk about Andrew's. Okay, very similar. Let's talk about Andrew's idea. Let me put it down. What he said was, he said result is assigned to over here L plus content helper 2 ... Okay, although the ... over here is very important, right? Okay, I think that maybe you meant to say maybe I plus 1 over here, right? So somehow content helper 2 over here is going to return the linked list for the remaining part of the array. Okay, that's okay, Andrew. That's fine. Okay, so now I see some thoughts by Stephen. Let's see. Stephen said to store it into some variable and then append to the result. Yeah, actually that's pretty good. Okay, why don't we try Stephen's idea? Okay, so now I would say what Stephen meant to say is we need a local variable here. Okay, that's also on my solution. Let's say we have a sublist. You can think about a sublist is going to be the linked list from array index I plus 1, I plus 2, all the way to the end, right? So sublist over here is going to be a linked list of string. And it shouldn't be, so Andrew, if you don't mind, I'm going to wipe out your solution over here. The idea is on track, but we just need the correct syntax. So now we're going to say sublist is assigned to over here, contents helper. Helper 2. Okay, this guy here, right? So now we're going to say the rest of the array. So not including the current I. So we're going to say I plus 1. However, now the problem is over here, sublist is actually, okay, you might be tempted to write the following. You might be. So you might say result dot extend. And then you can simply say sublist, for example. Conceptually, I would know what you mean. Okay. So now, however, if you try to compile, it's going to say, no, it's actually non-compatible, right? It's a non-compatible actual argument in the feature call. The reason is very simple. You can read the error message by yourself. What it's saying is, whenever you say extend, as we show in the tutorial video, you can only extend by a single item, but not the whole list, okay? You can look up the linked list to see what feature might be helpful, but I would say from what you learned in Lab 0, you know how to solve this. You can just use a cross loop, okay? Why don't I do that for you, okay? I can say over here, across, and then cross loop, and then across the sublist, right? Each one of them will be a string. So ls for local string. And then rather than extend the entire list at one go, I can extend them one by one.
Professor?
Yeah, so let me finish this and I'll take a question, please. Okay. And then I would say result over here dot extend over here ls. Let me just make sure everything compile. Okay, there's some issue here. Let me take a look very quickly. Is maybe okay. Maybe that's what you meant to say to me. I guess maybe something else. Okay, it's not compiling. Okay, I'll take question in just one moment. So I think that's about the recursion over here. You can think about it and we'll consult with me later. Or if you want to ask about this particular recursion on the forum, that's fine too. Okay, think about it. So basically I show you both flavors about how you can write recursion. So hopefully that will be enough hints for you to complete the recursion for your Lab 1. Okay, because in general recursion the format is pretty much there. So just about how creative you are to solve individual problem. So okay, let's finish the test very quickly for you. So I would say I will simply just copy this block over here and then paste it. I'll just need to rename that to be 2. And then that'll be 2. So everything is similar except for it should be contents 2, right? And then I will simply go back here and then I'll say add Boolean case. And then, okay, so now recursion 2, compile. And now let's make sure everything's working. Good. All right. Guys, any questions specific to the recursion, first of all? Everything is straightforward to you, I hope. So I think the main intention really is to really show you the two flavors of the recursion. Okay. And Eric said, can we use either version? Yes, you may. You may, yes. Yeah, I intentionally try to show you the most general structure for your recursion. And then you can either use recursive query or you can use recursive command. You can choose either one. Okay, apply that to your Lab 1. That's absolutely no problem. You're encouraged to. Okay. The first version is just more familiar. Sure, no problem. That might be actually what you were forced to do if you took 2030 with me. That's the format I forced. But for version number 2, that might be useful at some points. Yeah. Can I post the example in eClass? Yes, I will do. I will post the this particular coding example on the lectures page so that it's public. Okay. But I would suggest not just to reuse the code directly. You may want to understand what's going on because I try to make the problem quite different from the tree. Because I think it should be your problem to solve the tree. I'll just give you some guidance on the syntax. Okay, I'll make sure this code is available to you. That's not a problem. Okay. All right, so it seems like we are okay with this particular recursion. There's one more thing I would like to talk about on my agenda, and then I'll take your questions, okay, on the Google Doc and also on the chat. Okay, so I'll go back to the chat in a moment. Okay, I'm just looking very quickly. There's nothing more about this recursion here. No, okay, so so now we are saying goodbye to this example here. Let me close it, okay? Okay, so I'll come back to the starter code only if necessary. But now I want to talk one thing on your instruction. I want to help you read that particular part. So if you go to section 4, okay? If I were to teach you 2011, this will be the most exciting part I would like to teach you because this involves quite a bit of drawing and illustration. But I only just do one very quickly. Okay, I want to help you just how to understand this. So you got one section here about rotation. You got the next section there called splay operation, right? I'll just do one case to give you the idea. You can apply the same reasoning or understanding for the rest. Okay, so again, this is the part that's more advanced and intermediate. So only do this after you have finished all the basic one, hopefully over the weekend or early next week. Okay, so you got enough time to do the split tree. Okay, so now what I would like to talk about is how do you understand this particular rotation over here. Okay, I want to help you with that. Okay, so let me switch to my iPad and then I'll give you some intuition here, a little bit of reasoning, a little bit, so you understand why things are doing this way. Okay, so that's case number 2 from your instruction there. Okay, for rotation. Okay, so now how do you think of it? Okay, so every time when you do rotation, there should be a target node on which you want to rotate, right? And our color convention is the node you want to rotate will be green N, and also the blue one is NP, the parents of N, and also NGP, the grandparents of N, right? So now let's say for this particular case, we just show you some concrete example here. Okay, let me just show you quickly here, right? If you look at that, you can see the integer key we have is actually 1, and then 2, and then 5, and then 7, 8, 10, and 17, right? It's sorted. Well, what I just did, hopefully you notice I'm doing an in-order traversal, right? So the one important property about binary search tree, balanced or not, is really about when you do an in-order traversal, you will get a sorted sequence on their keys. It's a very important property, okay? So now for this particular rotation, the one we show you on the instruction is just one example. Now, how do you generalize it in order to encode it in your project, right? That's something we have to show you here. Okay, so now let's see this. The way to think about it is for the 3 nodes, you're going to do rotation, let's say N, NP, and also NGP, right? Think about their subtrees in general. So there will be 2 subtrees over here for N. So this is the left subtree of N, which can be in generally arbitrarily complicated, right? This is the right subtree of N. So let me call it T1 and T2, okay? And then this whole thing over here, even though it's more nodes, but it's just T3, the right subtree of NP, okay? And then this tree over here is just the T4, let's say, the right subtree of NGP. So in general, that's what you have. So let's say this. Let me just draw a little bit more clearly. You got N here, you got NP here. Also, you got NGP here, right? So now you're basically just talking about this subtree here, and also this is another subtree. Okay, let me be consistent with my arrow, sorry. Okay, and this is just the right subtree over here, right? So we got T1, T2, T3, and T4. Okay, that's the more general structure you have. Okay, so now think about how the rotation is going to do. Before that, you should know that rotation is only going to modify the structure of the tree, but it's not going to destroy the fact that it's a binary search tree, which means the search property should still be maintained. So now let's say this. If I want to do an in-order traversal of this particular tree before the rotation, okay, I'm just going to tell you right away. If you're not too sure why, you can speak to me later. So if I do an in-order traversal, it should be T1, followed by N, followed by T2, followed by NP, followed by T3, followed by NGP, followed by T4. Okay, so now if you think about T1, N, T2, NP, T3, NGP, and T4. That's exactly how you do in-order traversal, right? So that's the in-order sequence we would like to maintain before and after the rotation. The in-order traversal should be the same. So now, if you think a little bit more, so now, after the rotation, how should the subtree look like? So I'll just tell you right away. So this is still T1. Whatever T1 was before the rotation, now they should be the left child, still be the left child of N. And then this guy here will be T2. You can see for T2 specifically, right? Let's see what the change is. T2 used to be the right child of N before the rotation, but it now becomes the left child of NP, right? That's a structural change. And then let's say this guy here, let me move a little bit. So this one over here will be T3, and this one over here will be T4. So now the structure has been changed completely, but now have we actually maintained the in-order like a search property for the binary search tree? The answer is yes, we do. Because now if you try to do the in-order traversal, you're going to get T1, N, T2, NP, T3, NGP, and T4. And that's exactly the same sequence over here. So that's why after rotation, the tree still satisfies the search property. However, just a structural change has been made. Okay, so now why am I showing this? The reason is just by seeing the example from the instruction is not enough. You have to also generalize the pattern like this in order to program that accordingly. Well, of course, you may have to change the pointers for parents, for left child and right child. So that's the programming details you have to work out. Okay, but hopefully conceptually that makes sense to you. All right. Okay, I think that's about the last item I would like to talk about from my side. I believe that's enough for now. Okay, so let me now go over some stuff over here. Let me start on the Google Doc, right? We may have fewer questions over there. Let me just go over there. Okay, we have some over here. Okay, first of all, we got question number from Ken. How do you use loop or recursion to go through a tree? Okay, so I would say you're right. In order to really do something about a tree, you can either do iteratively using a loop, or you can do recursively, right? So now without diving into too many details, right? Let's say this. Let's say I simply got, let's say, let me just draw an example tree. 23, let's say 46, 69, 89, and then, oh no, 100. Okay, it's a binary search tree. So now, for example, if I simply want to print out all the nodes, to, right? So what I would do is I need to do, if I want to say, I want to print, let's say this is the root of the tree, right? You can think about each node I'm showing here. I'm only showing you the key value, right? Because it's sorted by the keys. If I say print from R over here, so why you should, let's say you learn about pre-order traversal as well, right? So what will be the pre-order traversal, right? You will print out, in order to call this particular recursion here, so first of all, you will print over here. You'll simply print out 89. So that's the root, right? And then you have to recursively print out the left subtree, right? The way to do it, you're going to say print, maybe r dot left. And then you also got to recursively print out print and then r dot right. So that will cover the right subtree. And of course, there will, it's like a recursion, you have to move on, okay? And then if you try to print this out, it will eventually give you the result, let's say 46, and then 23, and then 69. I'm sure you know why, okay? I'm not gonna bother you with that. And then for this one here, it will just be the base case, it will just be 100, right? So that'll be the eventual result. So I believe, Ken, that should be enough for you to move on, right? So how you call recursion on tree. You have to know in each recursion, you got to do a little bit of computation, and then you got to pass on to the recursion, okay? All right. That's about question number one. Question number two, can you use data structures such as stack or queue, and how would you do this? Possibly tree traversal, okay? Andrew was asking this question. I think that's good. Basically, Andrew might be thinking about something very specific to his implementation about using a queue or using a stack, okay? I wouldn't go too much detail to it because that's Andrew's thought. What I would do instead is you may want to look at Eiffel Studio over here. And then if you look at the class here, okay? So remember in Lab 0, I gave you some hints about how you can search for example, some class. You can use the regular expression, right? You can say, for example, if I put stack over here, so you can see we got something over here, array stack, for example. So that's some class you can use. If I go there, I'm not saying you have to use it. If you think that might be useful, you can use any library class you like. And then you can see they got features over here. They got make from iterable, they got extend, they got put, they got force, not so many features. So you can look into it. And then how do you use it? Just create a stack using the constructor and also call their commands or queries. If you find that the library, if you find that the library classes that's available to you may not be so satisfactory, you may have to just create your own classes or your own helper routines in your in the tree nodes or in display tree. That's what you got to do. Okay, and then let's see what else. And Andrew, just another comments for you. So in order for you to use, let's say if you really want to use let's say queue or stack, why don't you use an array or to use a linked list as if it's a queue or as if it's a stack? Because what makes the difference between array and also a stack, for example, is for a stack, you cannot just get access to any indexing, any particular index. You just have to make sure you access the array in a last in, first out fashion. Then it will be a stack for you already. So you don't necessarily need a library class. So Andrew, I hope that answered your question. I hope. All right. Okay, so that's about, okay, let me just, for those that's done, okay, I'll just put blue over here, okay. How can we use attributes, we got from Amir. How can we use attributes defined in class of tree node more efficiently, such as left parents? Well, I'm not too sure what you mean by efficient, okay? But let's say, for example, is it syntactically or logically valid to use left account or current account? Yeah, it is valid. You can say left account, you can say current parents, you can use it if you think that's applicable. However, be careful, because for left, if you look up the declaration for left in tree nodes, it's detachable, which means it might be void. In order to call left account, you have to check to see if that's attached. So what do I mean by attached? You gotta look up the video in Lab1. All right. Can I explain the that's from Shivek? So can you explain the postcondition of count? Okay. By the way, you shouldn't say method anymore. It should be a count routine or count query or command, right? Say I'm able to count the number of the descendants. I'll try to explain to you the we shouldn't go over too many details about your implementation. We shouldn't. Okay. Okay, I'll just see this one. I will go to the postcondition for count in just a moment. Okay, we'll go there. How can we cast attach variable to detach variable? No, you cannot do it. You can only cast from detachable variable to attach variable and semyak, right? So I might know what you mean. Okay, let me just do a little bit of stuff over here. Okay, and then I'll go back to Shivank about count. So let's say this. The detachable cast we did in Lab0 is about the return value from get detachable birthday, right? That's what we did. So let's now do another example here. Let's just make it very easy. Let's say class over here, person. Okay, let's say over here, of course, we got name, we got other attributes. Let's say we have one single attribute over here, let's say called spouse, right? Not necessarily everybody got a spouse, so it would just be detachable. So I would say detachable over here. Detachable, just another person. Okay, so now let's say we can have one invariant over here. Okay, so now what should we do? Okay, let's say we want to specify the following constraint to say your spouse's spouse should be yourself. Make sense? If you have a spouse, if they exist, their spouse should be you. Otherwise, it will be strange, right? So now let's see how we can encode this invariant over here, right? So now, if I simply write the following, okay, so now let's try, okay. Should I say legal over here? Okay, if I simply say you don't necessarily have to use current, but if you like, you can use it. Current dot spouse dot spouse should be the same as current. You might have seen this example here. Maybe if you took maybe 2030 with me previously, I might have used this maybe in Java. Okay, but now it's actually nice because we can specify an invariance to actually talk about it. Okay, so now guys, question for you. If you put this invariant in iPhone Studio, would it compile? Anybody? For those of you who might know what issue I might want to address, you can speak up if you like. Do you think this will compile? Anybody? You can say yes, you can say no. If you say no, you can explain to me why. Anyone?
No.
Let me check it. No? Okay, I heard no. Yes. Who is this, please?
Anto.
Oh, hi. Yes.
Yeah.
Yeah, okay. Why do you think no, please? Why do you think no?
Because the suppose variable is void and you can't use dot operator on that.
Yes, exactly right. So thank you. So now, because we say that the spouse over here is simply just detachable, which means may not be void, but it might be void. Yes or no, right? So it's sorry, it's not, we're not sure. It might be void, it may not be void. Okay. So now when we say current the spouse over here, so it might be void. Okay. So now the compiler will definitely complain. You can try this. Actually, very simple example for you to try here so you can see what kind of error message you will get. I believe they will simply say spouse here might be void. Okay. How can we fix it, right? That's what we have to know. The way to fix it is we have to assert to the compiler that we do care. We will only make this particular call to call spouse when the spouse is actually not void. But how do we do that? Okay, so I'll show you the solution. Actually, I'll show you two possible solutions. How about that? But logically, you have to be careful. Okay, let me use possibly blue over here. Okay, so I got two solutions for you, right? Both of them will fix the compilation problem, but only one of them will fix the logical problem as well, right? Let's say number one, I would say let me ignore the current for now. Spells. Oh, actually, I gotta use attached. So attach, as I said before in the tutorial video, is to check to see whether it's not void, right? It's a keyword, excuse me, it's a keyword, attached spouse. And, okay, it's a logical conjunction, and then you can remember the section about the important syntax to learn in the instruction. So I talk about and then as well. It's like a basically ampersand in Java with a short circuit, right? And then you can say spouse dot spouse equals. I'm just running out of space, but it should be in the same line. Okay, let me give you version number 2. Okay, version number 2, I can say attached spouse implies spouse dot spouse dot spouse equals by address current. Guys, I think it's worth having some discussion here because either one or two will fix the compilation problem, but that's not shouldn't be where we stop because you don't just want your code to compile, you want it to be correct. I'll pause a little bit. It might be nice for you to learn. Between 1 and 2, which one should I choose? Why don't we just know which one, and then I will give you a chance to explain if you wish. Should it be 1 or 2? Which one is appropriate class invariant for us? 1 or 2? And for those of you who actually, Chauvin actually says he did something similar to 2, however, did not compile. I'm not sure exactly what you try. Maybe you can send me, you can communicate with me by email. And then, oh, I see what you mean, Chauvin. Actually, that's a good point. You know what? That's my bad. Let me do it again. Guys, beg your pardon. Chauvin is exactly right. Let me just fix that. I just forgot. Let me do it again. Every time when you do the attached, you want to make sure, okay, let me explain again. Thank you. So every time when you do attached, the reason that you want to check to see where the spouse is attached because it might be void. So from the compiler's point of view, whenever you use the spouse, it's just possible it could be void. So what you should do, as Chauvin actually said, so you know what? Let me write it properly. Okay. You know what? Let me open a new page. Okay, let me put it here. So this is the correct way to do it. Number 1, invariant could be attached spouse as, okay, so local variable we have to introduce. I'll explain to you once more, okay? And then I would say, and then local variable here, the spouse, okay, that's version number 1. I'll explain to you why it will work in just a moment. Number 2, attached spouse as ls over here implies ls dot spouse equals current. First of all, let me explain the mistake I made. Again, my apologies. So now here, the mistake I made was this. If you simply write, let's say you already checked to see attached, but now you simply say, let's say spouse dot spouse equals current. From the compiler's point of view, the spouse over here is simply just detachable. So whenever you refer to it, it just cannot be the targets for the call. So this will not compile. In order for you to really compromise for that, you have to say, I got this attached check over here. If it is satisfied, I'm going to let this particular ls. You can think in this way. Okay, a little bit more detail about runtime. Think about maybe spouse is actually pointing to maybe some person object, let's say, right? Okay, however, from the compiler's point of view, it's simply detachable. Because maybe at some point of the lifetime of this object, it might be pointing to void. Just at the moment, it is not. Okay. So now, what this particular expression will do is, as long as the spouse currently is not pointing to void, indeed, it is pointing to some person objects, and then it's going to create an alias. It's going to say ls is now actually going to point to just the same object. So we are not wasting any memory. We're just introducing a new variable. And then, so this one, as far as the compiler is concerned, it's just going to be of type person, which is by default attached. So that's why you have to use the ls over here rather than spouse. Okay, that's just clarifying. All right. And then, okay, this guy here just the same. So now, guys, I haven't really finished my question here. Let me just talk about it. So now, between version 1 and version 2, the difference is one version there use and then the other version there use implies. So is version 1 appropriates or version 2 appropriates? Anybody? 1 or 2? So we sorted out the compilation problem already, thanks to Chavan. But now, what about the logical problem? Should it be 1 or 2? Which one is appropriate? It's very important to actually see the difference between and, conjunction, and implication. That's something we'll keep seeing actually, throughout the course. Anybody? 1 or 2?
1.
I heard you think 1 is appropriate?
Yes.
Okay, that's okay. What's your name?
Parthiv.
Parthiv? Okay, sure, no problem. If you don't mind, let me challenge you a little bit, okay? Don't feel embarrassing anyway. So if you believe, let's say, 1 should be appropriate, that's okay. So now let me ask you this. What if we are talking about currently a person who's simply just single? A single person, nothing wrong with a single person, right? So now, for this particular single person, when you check their invariance, is it gonna be true or false?
It should be false.
It should be false because you can see for a single person, in that case, attached spouse over here would just be false. In that case, remember for conjunction, both sides must be true, but you already got one side that's false. So the whole thing will be false, which means you're going to have an invariant violation for a single person, which is not very nice. So that's why it's not appropriate. Okay, good.
Yeah.
Thank you. That's good. I'll write it down quickly for every one of you. Okay, so this is not appropriate. For example, I'll just say single person so you'll know what I mean. A single person will actually trigger a class invariant violation. On the other hand, so that's why I also mentioned in the tutorial video that every time if you want to do some kind of like a case analysis for your contracts, you may want to consider implies. Because in this case, what you will have is, let's say a single person. For a single person, their attached spouse will just be false, but that's okay. So false implies anything, so it will still be true, which means it's not going to violate the invariance. Okay. All right, so that's about the, so guys, I think this page is very important, even though not directly relevant to Lab 1, but it's about the syntax and also logic. So please make sure you get through it. It might appear at some point that you have to make a similar decision, okay? All right, so that's about a quick answer to your, about detachable and attach, right? I think that's pretty much what you need. Let me go over the question there. We may get another 10 minutes. Let me make sure I don't miss anybody. So I believe everything on the Google has gone over. Okay, this one has gone over. Okay. All right. So let's say question 5. Okay, let me just, how to cat, oh, that one has been answered already, Senyak. So, okay, the same. Okay, Google Docs done. Okay, let me close it. So now let me go to your chat. Let me see, I might have maybe a small number. Let's go over that. Okay, I'll just need to start from after the recursion, okay? Okay, so here's one question from Karen Dimp. So it would be helpful if there's a list of Java equivalents in IFO, like stack queue operation. It took me some time to simple stack pop because it needs 2 operations in IFO. Yeah, you know, I would say I agree with you. So every language, you know, when you do new language, the expected usage for their library classes might be different. I agree with you. That's something we got to get used to. However, I would say, let's say in this particular case for the stack or queue, you don't necessarily need a stack or queue class. You can just simply use an array or a list using the in a last in first out or first in first out fashion. So that will solve your problem, right? But other than that, you have to get used to the library structure or convention that for this particular language we're using. Yeah, that's a catch, I know. Okay, we got another question. Can I pass attach variable to your that? Let me read it more carefully. It's from Senyak. Can I pass attach variable to a feature that takes a detachable? Yes, indeed. Okay, I see what you mean. What you're asking is like this. Okay, let me just make it obvious here. So let's say this. You're basically asking the following question. So let's say if we got X, let's say we got a person class as before. Okay, let's say person. Okay, X and Y, they're both of type person, but somehow X is more constrained because X can never be void. Okay, and then Shiveng, oh, about the count. Yes, sorry, I forgot. Okay, I just got distracted by other question. I'll definitely get to it. Just bear with me. Okay, and then so now if I got, let me just put another thing over here. So now let's say we have some command, which will take some parameter P. Person over here. All right. Let's say command command 1, command 2. Let's say define maybe in the context of some other class. I want to show you exactly what Semyak is trying to ask. P over here, let's say detachable. Over here, and then we'll say person. All right. Okay, so that's about the setup. Okay, so now what I want to ask you would be how the compiler will actually treat them if you're trying to use them together. So let me give you different options over here, right? Let's start with a simple one. Guys, number 1 and number 2. Will number 1 compile? Number 1, would it compile? No, from Ken. Okay, no. You want to explain quickly why? Anybody want to explain before I try to explain to you? Go ahead.
Is that because like detachable can be void, so it's like you can't be void to imply void? It just doesn't make sense.
Yeah, yeah, you're basically right. Okay, so now think about the type. For X over here, it's a person, right? So X can never be void. Never be void. On the other hand, for Y over here, it's detachable, right? So it might be void. That's not good. So you cannot, it's almost like it's possible you simply assign Y, which is void, into X, which is not allowed to void. So the compiler wouldn't allow that. Logically it makes sense. On the other hand, if you look at number 2 over here, that'll be okay. Because Y is actually maybe void anyway, but if you assign that something that's always not void, that's fine, right? You're just giving something that's always guaranteed to be not void. So 1 and 2, okay? So 1 is gonna have some compilation error, but 2, no, it's okay. Following the same logic before I get to the count. Let's say number 3, let's try to make some routine call, right? If I say command 1, X, command 2, Y. Guys, similar question. Will number 3 compile? And I give you a little bit hints for you to think about it. Think about how call by value work. Anybody? Will number 3 compile? Think about what number 3 will do. Okay, I heard from Ken, yes, 3 will work. Okay, that's correct answer because you can think about when we actually do this particular call over here, right? So it's really as if we're trying to do the parameter P over here is now replaced by, oh, so I should do assignment here. It's now assigned to the argument X. So now we're boiling down into this particular assignment. Can you assign X to P? Yeah, that's fine. X is attached, P is also attached. So that's okay. That's fine. On the other hand, so now can we do command 2 over here? This one also turned out to be okay, right? Because you can see this will boil down into P, because we're calling command 2. P is assigned to Y. P is detachable, and Y is also detachable. So that's also fine. So now let me give you one example that would not be fine. Okay, number 5. Okay, what about I say command number 1, but I try to pass Y. So this one, hopefully now you can see it wouldn't work. Yeah, actually, this one wouldn't work because if you say command 1 over here, right? If you say P is simply assigned to Y, right? So Y is over here, and Y is detachable, which cannot be assigned to P, which is attached, right? Similar idea to this guy over here, similar, okay? So this wouldn't compile. And let me answer very quickly to Semyak. For Semyak, you actually said, what about command 2? X. Command 2X. Well, Semyak, how do you think? Do you think that will work?
I don't think so.
Sorry, you don't think so?
No, it will not work.
It will not work? Let's analyze that. Okay, so now
Sorry. It should work because
no, it should work. Okay, so
yeah,
now let's
should
think
work.
about what should be the learning process, reasoning process. We're talking about command number 2. So that means the P over here should be assigned to the argument X, right? So now you can see X over here is actually attached. And P over here is detachable, right? So now you definitely can assign something that's attached always to something that's detachable, but not vice versa. Okay, hopefully that clarified that. Okay, I think guys, that will also answer your question there. That's good. I like you guys' question. That's very nice. Okay, as I promised, I'm also gonna see the count. So let me just see the question very quickly. The postcondition of the count feature, okay, and give more hints. Okay, well, I'll see how much hints I can give. Since now we talked about the entire class, right? I gotta be fair. So now let me go back to the starter code for your projects, okay? So let me go to tree nodes, and then you want me to look at the postcondition of counts. Okay, I'm pretty sure this one you don't need me to explain, right? Complete this postcondition, right? And let's look at the hints. Return value of this query, which is an integer, is the same as the size of the linear version nodes. Okay, What about I give you just one example? I think that'll be the more hints you need. Okay, I'm just trying to interpret what that really means. Let's say this. Let me just make a simple tree. Again, let's say 23, 46, 89, 101, and also let's say 102, 105, 191. Let's say, okay, that's a tree. And let's say this guy over here is the root, right? When I say r.count, conceptually, we know how many nodes there are. 1, 2, 3, 4, 5, 6, 7, right? So we basically got seven nodes over there, right? Another way to check that this result is correct, well, of course, you can count one by one. That's one way to go. Another way to think about is the linear version of a tree is like an in-order traversal sequence you get, right? So now if you try to run an in-order traversal, which is covered by the nodes query, right? So that one there is going to be 23, 46, 89, 101, 102, 105, and 191. Agree? So now, what will be the size of this particular sequence? 1, 2, 3, 4, 5, 6, 7, which match the count over here. I think that's the hint you're looking for. Okay, makes sense to you? I hope. All right. I got another question here by, okay, actually one by Eric, one by Rain. Okay, if you guys don't mind staying a little bit longer, okay, let me just answer them since you're here. For Eric, I'm still a little bit confused about what an external node is. So an external basically is like the node of the tree, the leaf node, yes, okay. How kind of diagrams? Okay, so let me try to clarify this over here, okay. Eric, I think, I'm not sure if you joined late. I also talk a little bit about the internal node versus external node in the beginning. You can check that out as well. Let me try to say this over here. Internal nodes looks like this. External nodes looks like this. Let me only talk about the key value. Okay, that'll be easier. That's a key value. Let's say the key value is simply just string. So maybe I put A here, okay? And then for internal nodes, of course, both left and right cannot be void. And now the thing is, if they are not void, for internal nodes, it could be external, the left child, or it can be internal. And also for right child, it can be internal, or it could be, it can be, it can be external over here, or this one here can be internal or external, either way, right? That's internal nodes. So now for the external nodes itself, the key over here might be, if you look at the declaration in the tree nodes, it's detachable for the key. So now in the case of reference type, it will just be void, the key value. It would be slightly like a special case. Let's say if the key value is simply just primitive type, let's say integer. Okay, somebody just joined in. That's interesting. I think I should let him in. So in case where the key values are simply just primitive type, let's say integer or Boolean, in that case, for primitive type, like in Java, we don't really say an integer value can just be null, right? Like in Java, similar in iPhone. So you wouldn't say a primitive type like an integer, Boolean, or character or real can be void. So now, in the case where the key values of a primitive type, you will simply just keep the default value. But we can just talk about reference type in general, okay? So now for reference type, it will just be void for the key, and also for the left, it will just be void, and also for the right, it will also be void. Okay, hopefully, Eric, that answered your question. Okay, some question from Rain. Good. From Rain over, okay, for the last section in the instructions PDF, do you need to worry about doing anything or this? Okay. So Rain, I would say, if you don't mind, okay, guys, let me emphasize again. The changes we made, the last changes we made to the starter code was on Wednesday, 10:30 a.m., okay? It's very minor change, just about the typos, okay? So I would suggest, if you have not done much development work, if you haven't, okay, so I would suggest go to the E-class over here. We will try to minimize the changes we have to make, but if there are typos, we gotta fix them, right? So I would say this part over here, just about the changes that we made over here. Okay, do you have to manually make them? No, that's not your job, all right? So if you want to, I think the easiest way is you simply look at a timestamp of Lab1 starter code over here. You can see it's the 10:30, September 16th. So if you downloaded your starter project before that particular time, I would suggest, why don't you just re-download it? So you got it up to date without any typos, all right? So another question here, Kuma. So looking at Shivang's question for postcondition, can we introduce data structure in our feature? You're asking, can you introduce new attributes or new queries or new commands in your class, right? Yes, you can. You can introduce any local variables you like. Okay. Are you saying you want to create a new class for implementing list or creating a new class implementing stack? Is that what you mean? Oh, local variable, that's fine. Absolutely fine. You can introduce an attributes, you can introduce a new local variable, or you can introduce a new query, or you can introduce a new command. No constraint on that. All right. Okay, guys, I think I've answered all of your questions here. I really hope this helped you move on. Lab1, the main thing is really for you to really get through the syntax block for this new language we're using. Hopefully, starting from lab number 2, and especially lab 3 and the projects, you will see the real power of having your own design. That's something we'll like you to gain as much as possible, okay? I still got something here. Right, bear with me, I still got 1 or 2 questions quickly, okay? Local variables are given complaints and error in postcondition. Oh, good. Something I didn't mention. Okay, very good. I'm glad you mentioned that. Think about a very common mistake also is like this, okay? I'm glad you asked. I just didn't give you an example in the tutorial. Let's say if I got a query over here, or command, doesn't matter. If I got local variable x of type whatever, okay?
Professor?
Oh, sorry, hold it, please. Let me finish this. And then I will
yeah,
take
we
a break.
can't see your screen.
Oh, thank you. I think it's good that you interrupt. Absolutely. Thank you. Good. So let's say we have a query here, and then we got local variable x. And then require, okay, as I said before, require appears before local because local is part of the implementation. So that means the client is supposed to satisfy require first before you can move on to implementation. Okay, number 1, but this is kind of less common mistake. You cannot refer to local variable in the require. Okay, no, because local is supposed to be hidden. It should not be part of the interface. Easy. Okay, you can think about its implementation, so it should be hidden. Remember in lecture series number 2, when we talk about ADT, so we talk about how your module might implement the ADT. So one important thing is all the suppliers implementation details should be hidden. Okay. Okay. Let's now talk about your question about postcondition. If I say ensure over here, so now the question is, if you try to refer to local variable over here, you might think that will work. It would be nice, but no. The reason is local variable is hidden. It's supposed to be private. On the other hand, the contracts that we talk about, like an interface for your routine, require will be precondition, and this will be postcondition. So these are supposed to be public. That is why in the public interface, you should not mention anything that's private. So that's why it wouldn't compile. That's normal. Okay. So you cannot use any. Local variable in the postcondition. All right, so I believe I mentioned everything that people brought out a concern. Guys, any other questions before I let you go? All right, so as I said, I'm going to announce the extra lab sessions as you guys prefer on the survey. I'm still coordinating with the TA. I'll try to get back to you maybe by the end of Sunday. So please just make sure you check your announcement on the e-class. Is that survey? Oh, Andrew, you know what? I think Yeah, that's okay. So I think the survey there, I think we got the number of people we got over there. I think I can see the pattern pretty much. So I think adding your answer may not actually make a huge difference, but it's still open, you can try. But I don't think it's going to change the overall pattern anyway. So, but that's okay. I think I pretty much got everyone. All right. Guys, thank you for coming. So have a good weekend. If you really got trouble, please drop by my office hour on Monday. And also there will be office hour, the TA hours as well. All right. Good luck. And then I will see you soon. Take care.